video, we're taking a look at the roots of a cubic equation. One thing you should know about cubic equations right off the bat is that they always have 3 roots. A quadratic always has 2, a quartic always has 4, a quintic to the power of 5 always has 5. The thing about them is it doesn't always have to be real. So you might have some of them are real, some of them are imaginary. So that's something to keep note of and come back to when you're doing the functions chapter. If we take a look at this one and we take a look at all of the coefficients of this, so the coefficient here is 1, the coefficient here is -1, the coefficient here is 3, and the constant is 5. All of those numbers that I've highlighted in purple there are real numbers. And if it is the case that they are all real numbers, then you know that you can use the conjugate root theorem. So if they are all real numbers, no matter what the power is up here, it could be to the power of 5, to the power of 7. If all of their coefficients are real numbers, then go ahead and use the conjugate root theorem. So here I have z is equal to 1 plus 2i is a root. If I know that, I know the other root, which is the conjugate root. Z is equal to 1 minus 2i is also a root that we have. So that's something that you can write down straight away to get your marks, is that the conjugate is the other root. Now what I'm going to do is I'm going to combine these two things to make a quadratic for myself. And how I'm going to do that is I'm going to change these guys, which are currently roots, I'm going to convert them into factors. So factors mean that you bring it back over the equals to sign. So you're reversing all the processes that you would have ordinarily run through when solving a quadratic or a cubic. So bring them all back. So it's going to be z minus 1 minus 2i in one bracket. In the other bracket, I'm going to have z, it is z bar, but we can write it as z, minus 1 plus 2i. And then be careful, multiply those out. So take your time while you do it. Z by z, z by minus 1, and then z by plus 2. So if I do that out carefully for myself, I'm going to get z squared minus z plus 2zi. Then do the next lot. You're going to have minus 1 by z is minus z. Minus 1 by minus 1 is plus 1. Then do minus 1 by plus 2i, which is going to be minus 2i. Then go again, the whole thing, using your minus 2i. So I'm going to do minus 2i by z, and if I do that out, I'm going to get minus 2zi. The next one, I'm going to get plus 2i, and the last one, minus by a plus is a minus, 2 by 2 is 4, I by I is I squared. Now I'm going to start tidying these up. There is only one set of the z squares, so I don't need to do anything with him. He's just z squared, so I can write that down. Then I'm going to have the z's together, so let's give those a colour and work through them. So I'm going to have minus z, he's there, minus z there as well. Any others there does not appear to be, so I'm going to have minus 2z be the next thing. Now I'm going to look at the zi's, because that was another thing that I had, the zi's. So let's look at those. So I've got 2zi, and then up here minus 2zi. Well, what's going to happen there? I've added and then subtracted, so those eliminate each other. So those are gone. Then I'm going to do the real number, so the 1. So I've already used red, I've already used yellow, let's use another colour, green. So I've got plus 1, keep reading along, and I should have had a... Nope, that's it. So I've just got plus 1 for this one. Yeah, that's okay. So I've got plus 1 by plus 1 from that, or minus 1 by minus 1 gives me plus 1, came from that, that's okay. I'm going to write him down then. Then I'm going to look at the i's. So if I look at the i's then, what I'm going to have is minus 2i plus 2i, that'll go. They'll drop out. And then I've got minus 4i squared. What's special about I squared? You should know that when you have I squared, it's minus 1. So minus 1 by minus 4 is going to be plus 4. So that's everything kind of condensed down here, but I can of course tidy that up a little bit more for myself to make life a little bit easier. So I'm going to have z squared minus 2z plus 5 is what that worked out to be. Now If you're one with a good memory and you like to learn formula, you can of course learn off the formula where it talks about the sum and the product of the roots. I personally don't like learning off that formula because I always get them confused. Even now I have to look up what it is to remember it because I genuinely always confuse them. So I would recommend that you don't learn off any formula, that you're going to just multiply it out. So we're going to have that it is z squared minus the sum of the roots. So minus the sum of the roots times z plus the product. And that is not in the log tables, so if you are going to use it, you're going to need to learn it off. What we have to do now is we're actually going to have to use this quadratic, and there's two ways in which you can use it, and I'm going to show you that in the two separate parts, starting with long division. So in this part of the question, we're going to find the other root using long division. As I said, there's two ways of doing it. One way is using identities and introducing the z plus k factor, and the other is just simple long division. So whichever you prefer, go with that method. I'm going to do both. So long division, you start by saying z squared divided into z cubed, and you write the answer up here, it's z. Then you're going to multiply it down and put it under. So z by z squared gives me z cubed. I multiplied it down, I put it under. Z by minus 2z is going to be minus 2z squared. Z by plus 5 is plus 5z. I'm then going to have to subtract that. So remember, long division, when you multiply it down and put it under, you then take it away. So I'm going to say take away this. If I take away a negative, it actually becomes a positive, and I'm going to take away this. So that goes to 0. Then I've got minus z squared plus 2z. Well, that's just going to give me z squared. Then I'm going to have 3z minus 5z, that gives me minus 2z, and then I'm going to have plus 5 coming down. Then I'm going to divide z squared into z squared, that's going to give me 1. Now I multiply it down and I put it under, so I've got z squared, multiply it down, put it under, 2z, multiply it down, put it under, 5. Then remember, with long division, once you put it underneath, you're going to subtract it. So this becomes plus, this becomes minus, and look at that, it all drops out, which it should, because this is made up of the other factors. Now you know that the other factor that it was made up of when you divided it in is z plus 1. If that's the other factor, z plus 1, then you can find the other root. So z plus 1 is a factor, meaning that it should be a solution when it's equal to 0. So then you can bring your minus 1 over, or you bring your 1 over, so it becomes minus 1, and we're going to get z is equal to minus 1. So then you've got your three roots. You had your initial root, which was given in the question, 1 plus 2i. Remember then we could say straight away that the conjugate was equal to one of the other roots because of the conjugate root theorem. So you can in fact use the conjugate root theorem here because all of the coefficients were real numbers, and then we had minus 1. And that's it. There's your three roots. We got them using long division in this one. I'm going to show you how to use x plus k or z plus k in the second. For anybody who likes the identities kind of questions. So what I'm going to do is I'm going to set up an equation. Now obviously this is not a true statement, so I'm going to have to do something to make it a true statement. And that something is introduce the other factor, because if I have z squared here, to make it into a z cubed, I need to multiply it by something. And I'm going to multiply the whole thing by z, but remember there might have been another piece at play here, so what I'm going to do is I'm going to introduce the z plus k. Now what I'm going to do is multiply all of this out, and take your time while you do it because it's easy to make an error. But when I multiply out this side, I'm going to get z cubed, I'm going to get plus kz squared, I'm going to get minus 2z squared, and I'm going to get minus 2kz. Then I'm going to have positive 5z, and then I'm going to have plus 5k, and all of that should equal to z cubed minus z squared plus 3z plus 5. Now what I'm going to do is get out the colours and start assigning them colours. Is z cubed equal to z cubed? It is. So I know that I've got the first part of the factor right at least, and then I'm okay to continue. If it ever happened that the first two, or the highest powers on each side, did not align, so maybe you had a 2z squared on one side and a 2z squared on the other, or a 3z squared on the other, you'd have to go back and take a look at what factors you introduced. So make sure that the first two match. Then we're going to have kz squared minus 2z squared. That has to equal this. I'm going to set up equations in a moment's time. The z's here are equal to the z's here, and then we have our final part. Now you don't have to actually do all of them out to get out what your k is, because that's really all we're looking at. What was the k? So you can actually find it from the red part of the equation here. It's going to be 5k is equal to 5, so k is equal to positive 1. So you can, if you want, do all of them out, but if you're clever, you know you actually only need to do one of them. So if I did the other one, I get 2kz plus 5z is equal to 3z. Divide everything through by z here, and we get minus 2k plus 5 is equal to 3. Take away 5 from both sides, and I get minus 2 is equal to minus 2k. Divide by both sides by minus 2, and I get k is equal to 1. And you can take a guess, what do you think will happen if I set up the yellow equation? It'll give us the exact same thing, k is equal to 1. So I don't need to do all of them out in this case. I just wanted to find out what k was. And just like the other part of the question, if you watch the long division, I can now write the three roots. So remember, we were given at the start of the question 1 plus 2i. We knew, because all of the coefficients, the numbers in front of our z's, z squared, z cubes, all of those were real numbers. If you know that, then what you're allowed to do is use the conjugate root theorem. So the other is 1 minus 2i, and the last one is going to be 1, because we got k is equal to 1. And what we know from that is that z plus 1 is a factor. Sorry, it's not equal to 1, it's equal to minus 1. That's why I should have done this step. Z plus 1 is a factor, therefore z plus 1 equals to 0 is our little equation, and then we have z is equal to minus 1. So watch out for that. I made that mistake because I tried to wrap it up too quickly. Make sure you take the time to do this last step and you get out the factors correctly.